Relax, kid. No need to get worked up, okay?
A good sense of smell is magnificently represented in the animal kingdom. Whether it be terrestrial or aquatic, it will still be greater than that of a human's.
All you gotta do is look for the bare necessities, the simple bare necessities. Forget about your worries and your strife.
Bears are a part of the family Ursidae, and their sense of smell is acute. It is their most important sense for detecting food. Most bears can smell food sources such as dead carcasses and live animals from 1.5 kilometers away. Just by looking at a bear's head, it is apparent that they have very large noses. The size of their nose in relation to their head is a clear indication that they are excellent terrestrial smellers. Hundreds of tiny muscles are wired throughout a bear's nose and can be moved the way people move their fingers. When a scent is detected, it travels up two 9-inch channels covered in nasal mucosa that is 100 times greater than human. It then goes to a spot where 10 million nerve strands connected to 1 billion receptor cells fire electrical signals directly into the brain through countless tiny pathways and onto the brain's cribriform plate, which supports the olfactory bulb. The olfactory bulb is a neural structure of the forebrain of vertebrates involved in the sense of smell, and it influences skull length in carnivores such as bears. A larger bulb increases the sense of smell and requires a longer skull. In mammals, larger olfactory bulb size correlates with larger home range sizes.
Bears, as well as many mammals, have well-developed scrolls like bony plates in their nasal cavity called turbinate bones. These bones increase the surface area of the nasal passages and warm inhaled air to protect the lungs and aid in moisture retention. When comparing the percentage size of a brain that is allocated to olfactory systems, a bear's is at least 5 times greater than that of a human's brain, even though the bear's brain is 1/3 the size. A bear's brain weighs about 450 grams, but with an olfactory bulb with a size comparison of a thumb, compared to a human brain with the size of a pencil eraser weighing about 1,500 grams. A shark's sense of smell is a great competitor against the bear's. Sharks can easily use their sense of smell to distinguish and home in on prey by swimming in the direction of the growing scent. It can be described as locating a golf ball in the Loch Ness. It does this by using its nares to detect chemicals and odours in the water. A shark's nares are blind sacs located on the front of its snout and are not connected to the respiratory passageways. As a shark swims, scent-bearing water flows in an S-shaped pattern in and out of each olfactory pore.
The shape of the nair is designed to allow a continuous flow of water in and out of the nose. This is where the olfactory sac is found. The scented water travels into the olfactory sac. This cavity is packed tightly with a series of closely spaced parallel lamellae covered with chemoreceptors that act like air filters. This massive surface area increases the shark's sensitivity to smell, 10,000 times greater than a human's. As the scented water passes through the nostril, specific smells are distinguished by their matching receptor. When the right smell matches the right receptor, it stimulates a nerve cell that fires a message to the brain. This filtering process allows the shark to analyze the individual components of the scent. The shark is then able to identify and locate its prey by swimming in a zigzag pattern, comparing the strength of the scent in each nostril, then changing direction towards the strongest side. So when a point source releases chemical compounds into the ocean currents set up a swiftly dispersing odour passage. Eventually, this will bring the shark to the source of the odour. When comparing this to the bear's olfactory system, many similarities can be seen with the use of receptors sending signals to the brain, and in both animals, the olfactory bulb is larger than that of humans. The importance of smell for bears can be seen externally with the size of its muzzle, which is also used for respiratory breathing. In sharks, however, there is no shape of a nose present, only 2 slits that hold the olfactory bulbs, and these are not connected to breathing. In conclusion, it can be seen that sharks have a far better sense of smell in comparison to bears, yet throw humans in the mix and the size of our brain is the only physical way we can compete with these incredible predators.